Hey everyone, welcome to the Fargo 3D Printing Show today. Podcast 45, got a decently full podcast. So John, take it away.
Yeah, so one of the things we're going to talk about is why when you're doing 3D printed parts for a 3D printer, you should try and stick with ABS instead of PLA. So on the table here, and Jake is being the lovely assistant holding these up, we had a fan duct on our Replicator 2 printer go out. We had, a while ago, we had a print that there's something screwed up in the code, and it actually brought the print up into the extruder, so it caused the fan duct to melt.
Because that's when the MakerBot Rep 2s were doing the 99% complete,
right.
And then all of a sudden it start to move to the upper left-hand corner.
Yeah, so I think we talked about this in an earlier podcast. We even looked at our security cameras, and sure enough, in the middle of the night when there was a print finishing, we saw it slowly going up and into the extruder. So that caused the fan duct to melt. So we printed this replacement one right here in PLA just because we needed to print a quick fan duct. As you can tell, things didn't work out very well. The fan duct ends up being situated really close to the nozzle on the extruder. So PLA prints at a temperature of 230 degrees Celsius on the Replicator 2, and PLA has a much lower softening point. I think its glass temperature is somewhere in the probably 150, 160 degrees Celsius.
I can't remember off the top.
Yeah, I can't remember off the top. But that's way too close to have a PLA print to the nozzle. What ended up happening is we had a print where the raft didn't stick to the build plate, and so you had part of the raft coming up, which caused that fan duct to go even closer to the nozzle. So there's actually a little bit of ceramic insulation tape fused to this fan duct. We came back the next morning, and Eric, I think you're going to throw up a picture of what that looked like. It was a mess. I mean, it was exactly what you think a failed 3D print would look like. I mean, this was that, but to the extreme. Don't 3D print parts like that in PLA. So we printed more in ABS. ABS has a much higher, ABS doesn't have a glass transition temperature. So yeah, PLA, when it reaches a certain point, will actually turn into a liquid. It'll go from solid to liquid. That's why sometimes on PLA prints, if your nozzle isn't screwed in all the way, sometimes you'll actually see PLA leaking out. Has the consistency kind of warmed up maple syrup. You know, kind of runny, but but it's not quite like water. ABS, on the other hand, doesn't have a glass transition temperature. It actually turns into an amorphous solid. So even the softening point for ABS is higher than the glass transition temperature for PLA. So you don't want to use PLA parts where you're going to have a lot of heat. Another example of where you'd want to use ABS instead of PLA would, in case you're putting anything in your car. On a hot summer day, the inside of your car can get really hot, especially if the windows are rolled up and it's sunny and clear out.
Or outside too. I've seen a couple people on rain gutters will actually do an adapter for that. And I've had some people do it in PLA, some people do it in ABS. Like one guy, I think he lives a little bit farther north. What am I trying to say? I think he lives in Mission. That's what I was trying to figure out. There's no line there.
So you go far enough north, eventually you start heading south.
No, exactly. True. Very true. No, I think he was like in Michigan or something, in one of the northern states. That's what I was trying to say.
Okay.
And he printed out a PLA adapter for his rain gutter, and it actually lasted, I think, for a whole entire year outside. Granted, there was no impact as far as that goes. When you're having the rain run down it, there's the way the part was situated didn't have a big impact point, so that's probably why it didn't crack. But it was interesting to actually see that he's had that out there for more than a year now, where typically that would degrade because of the humidity and temperature and direct sunlight, where, like you said, ABS is a little bit more resistant to that.
Right, and the big thing with automotive stuff is if it's on the inside of the car, so kind of different from being on the outside. So rain gutter is not going to get quite as hot as something that's on the inside of a car, because in the summer, with the sun, with the windows rolled up, it basically turns into an oven. And to give you an idea of how hot it gets, in Fargo, sometimes we have temperatures around 95, 100 degrees. It's rare that we go over 100, but it does happen.
Yeah.
So
with humidity at like 100%.
Yeah, so the heat index ends up getting pretty high. So ABS, better for 3D printed parts on a 3D printer. PLA is okay, but ABS is going to be better, especially if it's anywhere near the extruder. So you can do PLA parts maybe for brackets, that sort of thing, something that's not going to be near a heat source.
Yeah, and Eric actually did cat fill on this.
Yeah.
So it's kind of an interesting, not really a...
So cat fill, explain when you say cat fill.
So when you print a part, there's actually, this is hollow on the inside, so there is a couple different ways of infill. So there's the rectilinear, which is back and forth. Then there's hexagonal, which MakerBot defaults to, and a lot of them I think default to that, where it has the hexagons inside of the part. That's the infill pattern. Very durable, or honeycomb if you want to call it that. Yeah. But instead of doing honeycomb, it does a little outline of a kitty cat. And there is really no structural integrity to it. It's just kind of neat. You can change that in the MakerBot software. I believe it's in the advanced side of things. You go down, I think, infill and something settings. You can change it from hexagonal to rectilinear, shark, or cat fill, I believe is the fourth. I think there's a fifth option. I can't remember. But I don't know. It's kind of neat. I think we'll try and get a decent picture of this. But it's I don't know. I'm not a fan of it because there's no practical use to it. It's just kind of like, it's there.
It looks cool.
And that's about it. So, I mean, if you're printing a cat, you can have cat fill on your cat. It'd be cat-tastic. So I guess that's the only other way. So if anybody's ever printed with the cat fill and has some really cool parts or something that they want to show off, put those in the comments down below, or throw it on our Facebook page. It'd be cool to see some other people using it for their parts.
Right. So the other thing is we're going to talk about the e-Nable project. So the e-Nable project, if you're not aware of what it is, it's these prosthetic hands. So the way that it works is you have two main parts, and they're hinged. So this is designed for people that have a congenital, they're born without a hand. So usually they still have some level of wrist flexing. So when you flex the wrist, it causes some strings to tighten, and that causes the fingers in the hand to open and close, to grasp. So this is a part that was actually printed in glass fill. The e-Nable project right now is making a big push for getting more 3D printed parts for the hands. And then they have events where all the participants in the event help to assemble the hands. They get all of the other hardware put together, the strings, the elastic bands, all of that stuff to try and build all of these hands, because there's a lot of people out there that need and could really benefit from these hands. So there are, you have your basic e-Nable hand, and then there are other types of prosthetic hands out there. So 3D printing in prosthetics is huge, especially for helping to bring costs down, helping to make it more accessible. And this is really huge for kids, because kids will grow out of they'll grow out of their prosthetic hand.
Fast.
And if you're spending $40,000 on each hand, that really starts to add up. There's another group that we work with, Protosthetics. They have a hand, but instead of having the flexing of the wrist, causing it to open and close, they actually use myoelectric interface. So little sensors you put on your arms, and then that detects impulses from the nerves, and that actually causes motors to open and close. And in some of the different joints, I think they have an elbow joint.
I think they even have an elbow joint.
I think they have
which is really neat.
Yeah, so it's pretty impressive. So 3D printing in prosthetics is very huge. If you're looking to get involved in the e-Nable project, go to enablingthefuture.com. Definitely check out their Google Plus community. They have a lot of other instructions there. You have a lot of people that are really involved in the design of these hands and helping to get them put into use, making them connected with people that really could use these.
Yeah, and I think there's a whole Google Plus community. I think there's another community out there, because I think that's one I learned of, and I think I joined it probably 2 years ago. Is when I started to kind of hear about it and start dabbling with it. Never printed anything for the project, but was always intrigued by it.
Yeah, so it's really growing. Definitely a very good thing to take part in. But I think for this week, that covers it. Jake, unless you have anything else?
No. So this is kind of neat. I know, Eric, you mentioned...
No, I don't have anything else, but here's this other side.
Sorry, I was like, oh, hey, this is kind of neat. So this group, I can't... Eric, do you remember the... I'm blanking out. It's been a long week. But so this is kind of a cute little animal. This was printed in a couple different parts. And I think they have a panda. This is a rhino. So it's kind of a little bit of a neat thing to have. Might give that to my nephew.
It's kind of like a fidget cube for you right now.
It is, because it's like, So, but no, those are kind of neat. Check those out. I'll have Eric put a link down below so that you guys can go find those.
Yeah. All right. Well, on behalf of myself, John Schneider, and Jake Clark, we want to thank you for listening and/or watching another episode of the Fargo 3D Printing Show. Like we said, all the links are going to be down in the show notes. If you have any questions on anything we talked about today or suggestions for future things to talk about, please let us know. Just leave something down in the comments or send an email to support@fargo3dprinting.com. If you haven't already, subscribe to us so you don't miss out on any other episodes of the show. We're always
cool stuff coming up.
Yeah, we have some really cool stuff coming up this fall. So again, on behalf of both of us, thanks for listening.
Yeah. My name is Jake.
Oh, another thing I'm going to talk about is an SLS printer called the Sintratec.
Sure.
I'll just talk about it.
I'm just going to let you handle it today.
Okay.